As you saw in the videos that were homework last night, an atom is made up of mostly empty space with electrons zooming around in a cloud outside a very densely packed nucleus made of protons and neutrons. The charge on the electrons is negative, and the charge on protons is positive. The attractions between the plus and minus charges keep the electrons from flying away. Neutrons, shown in green here, are neutral. So we have our negatively charged electrons outside the nucleus, and they're constantly moving in a cloud. We have our positively charged protons, shown in red, inside the nucleus. And we have our neutral, no charge neutrons, shown in the nucleus in green. You're going to work on a handout today where you're finding out the mass of atoms, and you're also using that information to find the number of protons and neutrons, and you're also going to be finding the number of electrons. But before you do that work, there's something you need to understand. Electrons are tiny compared to protons and neutrons. If a proton or neutron, which have about the same mass, if they had the mass of a bowling ball, then an electron, with its negative charge, would have about the mass of a penny. Because there's such a big difference there, we don't consider the electrons when we're finding the mass of an atom. And again, neutrons and protons have about the same mass, and the mass of each is called 1 AMU, an atomic mass unit. When you look at a periodic table, each element will have the following information. We'll have the atomic number, and this number tells you the number of protons in the nucleus of the atom. So for oxygen, the atomic number is 8. Because protons have a positive charge and electrons have a negative charge, atoms have the same number of electrons and protons. Each positive proton in the nucleus attracts a negative electron that's flying around in the cloud outside the nucleus. The atomic number doesn't tell you anything about neutrons, and we'll get to that soon. The number of protons determines what an element is. The number of protons for an element never changes. Periodic table entries also tell you the element symbol and the element name. If there are two letters in an element symbol, like Cu for copper, the second letter must be lowercase. The number at the bottom edge of a periodic table entry, circled here in blue, shows the atomic mass. Because protons and neutrons have about the same mass, the atomic mass of an atom is equal to protons plus neutrons. We don't count electrons because they're too tiny to affect the mass in a way that we can measure. You'll notice in this example that the atomic mass is not a whole number. To find the number of protons and neutrons, you first round the atomic mass to the closest whole number. For our example, it would be 16 AMU, or atomic mass units. Next, subtract the number of protons from the atomic mass. And you'll remember that the atomic number up top is equal to the number of protons. So we have 16 minus 8, which is our number of protons. And when we solve that, we end up with 8, which is our number of neutrons. Protons plus neutrons equal the atomic mass. You're going to be working through a handout to be sure that you understand the principles that I just talked about. The first step, the easiest step, is to fill in the element symbol and or the name. We'll take a look at zinc in the center because we just did oxygen in that first example. So for zinc, I look on the periodic table. I find the element with the atomic number 30, and I can see that the chemical symbol for zinc is Zn, and you'll notice that I use a lowercase n. Again, remember, if there are two letters in the symbol, you use a lowercase letter for the second letter and an uppercase letter for the first letter. The next thing you're going to want to do is to write down the atomic number and fill in the number of protons and electrons. You'll remember that the atomic number is written at the top, so we write 30 in here. That tells us the number of protons in an atom of zinc. So I write 30 for the number of protons, and because protons have a positive charge and electrons have a negative charge, for every atom the number of protons is equal to the number of electrons. So I can fill in 30 down here for the number of electrons. If the space is blank, the next thing you're going to do is record the atomic mass. So for zinc it would be 65.39. Then the last thing I need to do is find the number of neutrons. You'll remember that to do that I need to first round the atomic mass to the nearest whole number. So for zinc that would be 65. So I've rounded that off. Then you do the math. You do the rounded atomic mass minus the number of protons, and that's going to equal the number of neutrons. So here our number of protons is 30. When I do that math, I find that I have 35 neutrons. The number of neutrons doesn't depend on the number of protons. Remember that the number of protons equals the number of electrons, but atoms can have different numbers of neutrons.